my dear PU2 students, and welcome to Deeksha Karnataka YouTube channel. And today I am going to start the new series where I am going to discuss all the model papers one by one. So all the teachers will be doing their model papers. Every week we are trying to give you one model paper, and today I am going to give you the first model paper of physics. It will be followed on by other subjects as well. So don't worry, all the model papers will be solved completely in our channel only. So if you want the solution of entire paper, not just the MCQs, then you have to subscribe to our channel and obviously like this video so that we get the encouragement to make more such videos for you, right? So without any delay, let us start with the model paper number 1. So first, obviously you are aware of the question paper pattern. So if you are not aware, let me tell you that there will be 15 MCQ questions, then there will be 5 fill in the blanks question. Both comes under section A. Both are compulsory. There is no extra options in section A. In section B, you will get 8 2-marker question. Out of that, any 5 you have to answer. So you get options there. In section C, you get 8 3-marker questions. Again, you have to answer any 5 of them. In section D, you will get 5 5-marker question. Out of that, any 3 you have to answer. Again, there are options. And in section E, you have to answer 2 numerical questions out of 4, right? So this is the basic question paper pattern, and we will, as obviously, will start with MCQs. So, and most of you generally struggle with MCQs, so I will also give you some tips and tricks. If you don't know how to answer the MCQ, if you are not aware of the correct answer, then how can you guess the correct answer? That also I will tell you throughout this lecture. So don't go anywhere. Listen to me carefully. The electric flux over a closed surface enclosing a charged particle is minus q by 6 epsilon naught. The charge on the particle is. So this question is based on Gauss's law. Gauss's law states that the flux that is coming out of a closed surface is given by charge enclosed divided by epsilon naught. Now in this particular question, it is given as minus q by 6 epsilon naught. So these should be equal, and from there, if you calculate, you will get the charge enclosed by the surface is minus q upon 6. So correct answer is minus q upon 6. And in case you don't know Gauss's law, how to guess it, best way to see that minus sign is there, so definitely that charge will be negative, and q by 6 is there, so that means it will be q by 6. Okay, no, it will not be 6q. If 6q is coming over here, you could have guessed, okay, 6 is multiplied with q, that means it will be 6q, but here q is in division, so clear cut minus q by 6 should be the answer. Now next question, 2 capacitors of capacitance C1 and C2, obviously C1 is not equals to C2, are connected in parallel to an external source of potential difference V. The equation which is not applicable for the given combination is, symbols have their usual meaning. So we have 2 capacitances C1 and C2 are connected in parallel. So here we have 2 capacitors. This is C1 and another one is C2. They are unequal capacitors and they are connected across a voltage source of voltage V. Okay, now what are conditions that we know will be applicable into this case? So first of all, they are connected in parallel. So in parallel means the voltage across C1 and C2 should be equal. Okay, so voltage across C1, say V1, voltage across C2 is V2, then C1 should be equals to V1 should be equals to V2 equals to V. Okay, this is the basic combination, basic condition for parallel combination. Also in case of capacitor, we know that C equivalent should be equals to C1 plus C2. In parallel combination of capacitors, capacitance is added. So, and obviously what about the charges? So if charge in this is Q1, charge in this is Q2, total charge is Q, then Q equals to Q1 plus Q2. Okay, so these are all the known formulas. Let's see. Q equals to Q1 plus Q2, correct statement. Okay, C equals to C1 plus C2, again correct statement. V equals to V1 plus V2. So this statement is not matching with our basic concept of parallel combination, so this is the wrong statement. V1 equals to V2, V1 is equals to V2, so definitely this is the correct statement. So this is the only wrong statement, so that means this will be our correct answer for this case. So the question asked the equation which is not applicable, not applicable means only this one is not applicable for this case. So the question was slightly higher order thinking skill based question. It is not a straightforward question, so as you can understand. Now let's move on to the next question. In case of metals with increase of temperature, what happens? The conductivity decreases, the average speed of conduction electron decreases, the resistivity decreases, the number of conduction electron increases. Now let us understand one by one. The conductivity, so when you are increasing the temperature of a metal, it becomes a bad conductor, its conductivity decreases. So this is definitely, this is the correct answer and this is the correct option as well. Now other options are all wrong, they are actually opposite. In case of conduction electron remains unchanged, okay, even though its speed increases, total number of conduction electron remains same in case of metals, okay, it does not increase. Next, before I continue, I just wanted to tell you something very important. Those who are preparing for KCET exam and they are not finding any level that what I should study, what are all the questions that are going to come, what are all the concepts, those are important for KCET. Worry not, Deeksha Vedantu is presenting you KC90 crash course. Batch 1 is already running successfully. Batch 2 is going to be start very soon. And right now you can take admission in batch 2. What all you get? You will get everything that was offered in batch 1. But the price of batch 2 is less than that of batch 1. So if you are still waiting, don't wait anymore. You will get 8,999 as the cost for both Comet K and KCET. If you just want to study for KCET, the price is 4,999. For Comet K, the price is 4,999 again. So everything is covered starting from your entire syllabus coverage with chapter wise PYQs, DPPs. You will get KCET. DPP means daily practice paper. So each chapter solved, you will get a practice question paper as well to solve and to practice. Okay, KCET and Comet K Abhyas KCET test series absolutely free of cost for you. Live doubt solving will be there every week. There will be one live doubt solving session where all the teachers will come and discuss with you about your doubts. Downloadable, all the notes are downloadable and the PDFs are available. You will get exclusive WhatsApp community access as well, right? So with this note, I like to go to the next question, and if you are still waiting and if your dream is to get rank below 1000, then definitely this is the best choice that you have, right? Now let's move on to the next question. A galvanometer can be converted into a voltmeter by connecting a low resistance in series with it, a high resistance in parallel with it, a low resistance in parallel with it, a high resistance in series with it. So galvanometer can be converted into a voltmeter by connecting a high resistance in series with it. So correct answer option D. For ammeter, a low resistance in parallel. For voltmeter, high resistance in series. Next question. In the following table, column 1 is the list of magnetic property and column 2 is the list of an item related to magnetic property. Identify the correct match. So what are all the magnetic properties? Paramagnetism, diamagnetism, ferromagnetism. What are in the column 2? Magnetic property common to all substances. So which property is common to all substances? All substances are by nature diamagnetic. All substances by nature are diamagnetic, so 2 is matching with P. Let's see next point. Domain formation. Domain formation happens only in ferromagnetic material. Domain formation happens only in ferromagnetic material. So what is left? Sodium is an example for this property, that is definitely will be paramagnetic. So we get 2 is with P, 3 is with Q, and 1 is with R. So let's see how many of them are 1R. So 1R, 2 is P. So that means correct answer is option C. 1 is R, 2 is P, 3 is Q. Okay. Now, next question. Magnetic flux is a vector quantity or a scalar quantity? First of all, magnetic flux is given by B dot A. Okay, so magnetic flux is always a scalar quantity. Maybe a magnetic flux, maybe it is an electric flux. Flux is always a scalar quantity, and it is basically, its unit is Weber for magnetic flux. Okay, its unit is Weber. For electric flux, it is Newton meter coulomb per coulomb, Newton meter per coulomb, Newton meter square per coulomb, sorry. Okay, so it's a scalar quantity and its unit is Weber, not Weber meter square. Weber meter square will give you a different quantity, which is basically Weber per meter square will give you electric magnetic field itself. Okay, it is Weber only, not Weber per meter square or Weber meter square. Okay, it's a scalar quantity and SI unit is Weber. Now next, the resonance frequency of a series LCR circuit remains constant even if any variation in the values of. So what is the resonance frequency? So resonance frequency of an LCR circuit is given by 1 by 2 pi square root of LC. I have discussed this in detail in the Brahmastra series of alternating current chapter. So if you have not watched that chapter, definitely you can go and check that out. You will get one 5-marker question definitely in your upcoming pre-board exam as well as in your board exam as well. So the resonance frequency of a series LCR circuit, as you can see, depends on L as well as C. So if you change any one of them, L or C, the resonance frequency will change. But if you change R, resonance frequency will not change, because resonance frequency does not depend on R. Okay, so it is independent of R. So basically they asked you which quantity is independent of resonance frequency. Resonance frequency is independent of resistance. So if you change resistance, the resonance frequency will not change. Electromagnetic waves are produced by charges in uniform motion, stationary charges, accelerated charges. So electromagnetic waves are produced by accelerated charges. Next, a real object is placed between the pole and principal focus of a concave mirror. The image formed is, so a concave mirror is there, okay, and it is placed between the pole and the principal focus. Okay, give me a second. So it is placed between the principal focus and the pole of the mirror. So it will definitely produce a virtual enlarged image. Okay, so it will be virtual and magnified image. Next case, the waves coming from two coherent sources overlap at a point to give maximum intensity. The phase difference between the superposing waves may be. So we know that waves, when the waves are overlapping with each other, okay, if they are, the path difference is basically, if the path difference is even integer multiple of lambda, then we get constructive interference, which is the intensity increases. Okay, for constructive interference, delta x should be equals to n lambda. Now this is path difference. What is the relationship between path difference and phase difference? So phase difference, delta phi, is given by 2 pi by lambda into delta x. It does not matter is it a constructive interference or destructive interference, this relationship is always true. For this is for constructive, for destructive this is for constructive. Okay, Okay, for destructive, because in the final exam you might see the same question in terms of destructive and you are not able to answer because you are not aware. Okay, it will be 2n plus 1 lambda by 2. Okay, 2n plus 1 lambda by 2, it is the condition for destructive. Now relationship between phase difference and path difference is always this. So what is path difference for constructive interference? It is 2 pi by lambda into n pi, n lambda. So lambda cancels, so we get 2n pi. So any even multiple of pi should be can be an answer. Okay, so here if you see that 3, 5 and 7, all of them are odd number. Okay, but we know that 2n pi, if you put n equals to 1 you get 2 pi, if you get n equals to 2 you get 4 pi, if you put n is equal to 3 you get 6 pi. So only possible answer in this case is even number. Okay, because 2n pi is an even number. Okay, 2n plus 1 is an odd number. Okay, so this is a representation of an odd number. Okay, if you are wondering, 2n plus 1 represents odd number, whereas 2n represents an even number. So that means no matter whatever is the value of n, as long as n is an integer value, okay, n is an integer value, then 2n plus 1 will give you an odd number and 2n will give you a even number. So only even number among the option is 6 pi, and in case you don't know, you forget everything, you should see that all 3 numbers, 3 of them are odd numbers, only one of them is even number. That means it should be an even number, because possibly odd number answer cannot be possible. Okay, so this is a way to guess the correct answer. Now next question, identify the correct statement. Light waves exhibit diffraction but not sound wave. Okay, correct statement, they have asked you to find the correct statement. Now light waves as well as sound wave both shows diffraction. Sound waves exhibit diffraction but not light waves. As I mentioned, both shows diffraction. Light waves exhibit diffraction but not polarization. Now light waves do show diffraction as well as polarization. Sound waves do not show polarization. Light wave shows exhibit both diffraction and polarization. This is the correct statement. Okay, so light wave shows diffraction, interference, diffraction and polarization, all 3 things, whereas sound wave shows only interference and diffraction but no polarization. Okay, polarization is a property of electromagnetic waves only. Okay, but sound wave is a mechanical wave, it is not an electromagnetic wave, so it does not exhibit polarization properties. Now let's see the next question. In a photoelectric experiment, the graph related to 2 quantities is a straight line with slope equals to h by e. Then it's a graph of some options are given. So it is basically graph related to quantities, straight line in photoelectric experiment. First of all, this is related to photoelectric experiment and they are asking you to get a straight line with slope equals to h by e. Okay, so first of all let us understand what is the meaning of a straight line and what is a slope. So if you draw a straight line, okay, like this in xy coordinate system, so this is x, this is y, okay, this angle say theta, then what is the slope? We know that slope is given by m equals to tan theta. This is called slope of this straight line. Okay, now what is the equation of the straight line? The equation of the straight line can be written as y equals to mx plus c, where c is this cross section. Okay, so this is the straight line equation and this is where the mathematics is meeting with physics, right? Now we know that photoelectric means we have to use the photoelectric equation. So what is the photoelectric equation? Photoelectric equation states that the maximum kinetic energy of an electron emitted by photoelectric during photoelectric emission is equals to the energy of the photon, incident photon, minus the work function. Okay, so energy of the incident photon minus the work function is basically the maximum kinetic energy of the emitted electron. Now what is the energy of light? Energy of light is given by h nu, right? Nu is the frequency of the incident light, and work function can be treated as h nu naught, where nu naught is the minimum frequency required for photoelectric effect to happen, right? Threshold frequency. So this is the equation on the right hand side. What about on the left hand side? So on the left hand side, we know that the maximum kinetic energy can be expressed as E into Vs. What is Vs? Vs is the stopping potential. So now if you see that, you have to find a quantity with slope h upon E. So if you solve this on this here, you will get stopping potential equals to h upon E nu minus nu naught. So nu naught is a constant, so that can be considered as this. Okay, y is so this is your y axis, this is your x axis. So Vs is your y and nu as your x. So this becomes your y, this becomes your m, and this becomes your x, and multiplying this with the nu naught, you get c. Okay, c is not only nu naught, you have to multiply this h by e. H by e is a constant. Okay, so y is Vs, h by e is m, and nu is x. So you get that y is equal to mx plus c equation. So we can say this is a if you plot y versus x, that is stopping potential versus frequency, you will get a straight line with slope h upon e. So let's see stopping potential versus frequency of incident light. So stopping potential versus frequency of incident light. So no, remember that whenever we plot a graph, we say that y versus x. Okay, y versus x graph. So y comes first, x comes second. So y versus x graph. So stopping potential versus frequency. Stopping potential versus frequency will give you a graph which is matching our description of slope h upon e. Very interesting question. This type of question came in KCET once, okay, but the question language was different, so they have changed the language and now they have introduced this question in your PU board. Again, this is a higher order thinking level question, or we say this is a HOTS question. Okay, this question falls under HOTS. Okay, so difficult question. This question is a difficult question. Now let's move on to the next question. The total energy of electron revolving in nth orbit of hydrogen atom is least for. So total energy of electron is least when n is smallest. Okay, n is equals to -1. Okay, energy of an electron in nth orbit is given by, total energy is given by minus 13.6 divided by n square EV, right? We know that. So here, as you can see, smaller is n, higher is the higher is the magnitude of energy, but because there is a negative sign, okay, that means smaller the n, smallest will be the total energy. So total energy is smallest in lowest orbit, as it is going in the higher orbit. We say they are excited state. What is the meaning of excited state? Excited state means the electron energy of the electron is higher. So that means the smallest or lowest possible energy, total energy of electron, is at n equals to 1. Next question, an example of isobar. So what is isobar? We know isotopes. Isotopes is when both of them have same atomic number. Okay, means the number of protons should be same, only neutron number should be different. Okay, so that is isotopes. Okay, isobar is basically where two different elements have same number of proton plus neutron. If the proton plus neutron is same, okay, that is the atomic number is same, sorry, my mistake, atomic number or sorry, mass number is same, mass number is same, are called isobar. Okay, So this question is more common in chemistry, but this question is added in your physics model question paper. So from here you can say hydrogen and helium 3,2 are isobars. So they are called isobars. Now next question, when PN junction diode is reverse biased, both barrier height and width of depletion region increase. The barrier height increases but the width of the depletion region decreases. The barrier height decreases but the width of the depletion region decreases. Both the barrier height and width of the depletion region decreases. So first of all, let us understand. So here we have a PN junction. So if you apply reverse bias to a PN junction, what happens? The depletion region increases. So initially, suppose the depletion region was this. As you are applying reverse bias, the depletion region increases. Now as the depletion region increases, the barrier potential that is there will also increase. Okay, so barrier potential is the difference in potential between this end and this end. So this is, say, delta plus, this is delta minus. So what is the difference in potential? That is called barrier potential. So as the barrier height increases, the barrier potential also increases. Okay, so as the barrier height increases, barrier potential also increases. So we say that both barrier height and width of the depletion region increase. So correct answer option A for this question. Okay, now before I proceed, I just wanted to tell you that please join our WhatsApp channel if you want the downloadable PDF of this lecture, and also if you want to get notified about all the lectures, all the important series that is going to be coming in our channel. So please join the WhatsApp channel, and obviously if you have not yet subscribed to our channel, don't forget to subscribe to our channel. Now let's continue. Now it's time for me to discuss the fill in the blanks from model paper 1. The net magnetic moment acquired per unit volume of a sample is called magnetization. It is called magnetization. If you see in the option, it is called magnetization, and if you have any doubts, always see if the option is making any sense. So first of all, this is a model question paper, so there are lot of traps, so be careful. First option is magnetization, the net magnetic moment, so it is definitely related to something with magnetism. So magnetization is the only possible answer. Magnitude, even though it sounds like magnet, but you know magnitude means only the value, it does not have anything to do with magnet, so that's why magnetization is the correct answer. So correct answer for this one is magnetization. Lenz's law gives the dash of the induced EMF. Now here is a confusion. First confusion, Lenz's law gives the magnitude or polarity. So Lenz's law can give magnitude, it can give polarity, both are English language wise same, but answer you have to be careful. You have to know that Lenz's law gives the polarity of the induced EMF. It does not give you the magnitude. Magnitude is given by Faraday's law. So in same question, if the same question is asked, Faraday's law gives the dash of the induced EMF, Faraday's law gives the magnitude of the induced EMF, Lenz's law gives the polarity of the induced EMF. The phase difference between voltage and current in a pure resistive AC circuit. So it's a pure resistive AC circuit. So in pure resistive AC circuit, the phase difference between current and voltage is 0. So there, here if you see that there are 90-degree option is there is 0-degree option is there. Okay, so both again can be correct, but here because it's a pure resistor, for pure resistor the voltage, the phase difference is 0 between current and voltage. Next, if the angle of incidence for a ray of light in denser medium is equal to critical angle, then the angle of refraction in a rare medium is equal to, so this will be the angle where if you are light ray traveling from denser to rare medium, if the angle of incidence equals to critical angle, then it just goes grazing between the medium and the angle of refraction becomes 90 degrees. So this will be 90 degree, okay, not 0 degree. So in case you have any confusion, read other options, other questions as well, and when you are sure that this will be 0, this will be 90, mark it. Okay, so 90 is done. Last question, the minimum energy required by an electron to escape from the metal surface is called work function. So this is called work function. So correct answer for this will be work function. Obviously it is not called magnitude. Again, magnitude is not possible. Polarity is already done. So once everything is done, just see whatever are left, and from then you can answer the question. Now next, it's time for me to discuss the two marker questions. Define the electric field at a point. What is meant by source charge? So electric field at a point is the force experienced per unit positive test charge placed at that point in an electric field. So mathematically electric field is force divided by charge. Okay, so if you are placing a charge in a external electric field, okay, in some region in space, and whatever force is experienced by that charge, if you divide that force by the magnitude of the charge, you get electric field at that point. So electric field is the measurement of force per charge, okay, force per unit charge. Source charge is the charge that produces the electric field in the surrounding area or surrounding space. In other words, the original charge responsible for creating the electric effect experienced by other charges placed nearby is called source charge. So any one of them you can mention. You can mention the source charge is the charge that produces the electric field in the surrounding space, or you can mention it is the original charge which applies force on any charge kept near the surrounding of the charge. Okay, so this is the called source charge. Right? Now next, the electrostatic potential energy of a system of two like charges is positive. Explain. So before you start the explanation, you have to write the expression for electrostatic potential energy between two charges. So U equals to 1 by 4 pi epsilon naught Q1 Q2 by R. Okay, when two charges have the same sign, both positive or both negative. Okay, so they are asking you like charges, so they are not saying that both positive charges. Okay, it can be both positive or both negative, both cases it's like charges, right? So you have to mention both positive or both negative. Very, very careful, do not ignore this line. They repel each other due to electrostatic force. So when you are keeping two like charges nearby each other, they repel each other due to Coulomb electrostatic force. To bring these like charges closer together, you must do work against this repulsive force. The closer you try to bring them, okay, stronger the repulsion force become, and the more external work you need to do. Okay, so that's why the electrostatic potential energy between two like charges is positive. Okay, so closer they are, more work you need to do, that's why it is positive. Okay, if you are bringing them closer, and if you are not, you don't have to do any extra work, then their energy would be negative. Now next question, name the mobile charge carriers in metals. Write the expression for mobility in terms of average collision time, relaxation time for charge carriers. Okay, electrons are the mobile charge carriers in metals. Obviously, mobility in terms of relaxation time tau is given by E tau divided by m. E is the charge of electron and m is mass of electron. Okay, so mu equals to E tau by m. Okay, so remember this expression. Okay, also mu is drift velocity per unit electric field. This is also the definition of mobility. Next, what is the nature of force between two parallel conductors carrying current in the same direction, opposite direction? Parallel conductors carrying current in same direction attract each other and opposite direction repel each other. So parallel currents attract, anti-parallel currents repel. So this is called parallel currents when everything is same direction, but opposite direction means anti-parallel currents. Anti-parallel currents repel each other. Okay, easy question. calculate the magnetic energy stored in a coil of self-inductance 0.05 Henry carrying a current of 0.2 ampere. So remember that in each section of 2 marker and 3 marker there will be an easy type of numerical question. So even if you are very afraid of numerical question, you should try these numericals. They are very scoring, and even if you make small mistakes, you don't have to write anything for this. You just need to write the formula and apply the formula, solve it. For example, energy stored in a inductor is given by U equals to half Li square. Simple formula, one single formula, and you should be able to solve it. Every year this type of problem is there. Now inductance is given by 0.05 Henry and current is given by 0.2 ampere. So 0.2 whole square. Okay, so I square is there. Now let's put that half into 0.05 into 0.04. okay, 0.2 square means 0.04, so you cancel it, you get 0.02. if you multiply you will get 0.001. okay, you can use a calculator and check it. 0.001 joules or 1 into 10 to the power of minus 3 joules or 1 millijoules. okay, so correct answer here is 1 millijoule. If you are not sure, even if you leave the answer over here or even here, you will get full marks. If you leave the answer over here also, you will get full marks. So very simple, easy question. Don't ignore that small 2 marker question thinking that I am very afraid of numericals. Actually these numericals are very simple, nothing like 5 marker numericals. okay, so you should solve those numericals. Next, name the electromagnetic waves used in the radar system of aircraft, the laser assisted eye surgery, LASIK. okay, the radar system of aircraft is used microwaves, and LASIK is done by UV rays, okay, ultraviolet rays. okay, there is a specific range of ultraviolet rays, but we are not interested in that specification. It is not there in this textbook as well, so only the names will be sufficient. So radar system uses microwaves and LASIK uses UV rays. Next, give any 2 limitations of Bohr's atomic model. So Bohr model is applicable to hydrogen like atoms only. It cannot be extended even to mere 2 electron atoms such as helium. okay, so it is very restricted only for hydrogen like atom. While Bohr's model correctly predicts the frequencies of the light emitted by hydrogenic atoms, the model is unable to explain the relative intensities of the frequencies in the spectrum. okay, I have seen students, they only mention unable to explain the relative intensities of the frequencies. What is relative frequency? What is the meaning of that? So you have to mention that the frequency of spectrum. okay, spectrum means the light that you observe from hydrogen atom. okay, hydrogen atom when excited, as it is coming down to ground state, it emits different frequencies of light. Light means electromagnetic wave, not definitely light generally refers to our visible light, but here light means all electromagnetic waves. So you observe certain wavelengths, but even though you observe certain wavelengths and those frequencies can be correctly predicted by Bohr model, but some of them are very bright, some of them are very dim. So according to Bohr's model, everything should be equally bright, but that is not happening, and Bohr's model was not able to explain why some lines are very bright, some colors are very prominent, where some other colors are not that prominent. okay, so that was not being able to explain by Bohr's atomic model. Now let's move on to the next question. List out 2 differences between p-type and n-type semiconductors. So first of all, you have to mention doping element. For p-type you use trivalent, example boron, gallium. okay, n-type you use pentavalent, example phosphorus, arsenic. okay, Now in p-type majority carriers are holes, in n-type majority carriers are electron. There are many other examples, you can write them, but remember that p-type and n-type semiconductor both are derived from single semiconductors. For example, either silicon or germanium are used. Okay, so do not write silicon over here and germanium over there, that would be completely wrong. Okay, p-type and n-type both can be formed using silicon, both can be formed using germanium. I have seen students, they are writing example p-type semiconductor silicon, n-type is germanium, which is wrong. If you want to give some example, give the example of the dopant. For example, boron and gallium are used as trivalent and phosphorus and arsenic are used as pentavalent. Next question, derive an expression for, now we have completed all the 2 marker questions quickly. Let's move into the 3 marker section. Derive the expression for torque acting on a electric dipole placed in an uniform electric field. Very important question. From so far the questions that we have discussed, this is one of the most important questions, okay, because this question has come in the past in the in your previous year questions as well. Remaining questions are just reference type of questions, okay. Reference type means similar question or the question from the same chapter will come, but exact same question may not come, okay. So be careful, do not only study your model paper. Model paper will definitely help you to understand the level of the question, the difficulty of the question, but exact same questions generally do not come in PU board. There are only 10 to 20% questions that can come from your PU board, okay. From model paper. If you practice all 3 model papers, you should score about 30%. Each model paper you can get 10% of your final board exam. So if you study all 3 model papers, 30%, that is about 21 marks for physics you should get from your 3 model papers. That is the historical study that we have done in the past. Okay, but yes, these questions are important in your pre-board exam. So for scoring well in your pre-board, definitely follow your model paper. Now let's see. So this is, say, a charge, positive charge Q, this is a negative charge minus Q, okay, and this is an electric field E. What happens when you keep the dipole in an electric field? It experiences force, okay. Positive charge experiences force in this direction, okay, F plus, and negative charge experiences force in the opposite direction of the electric field, F minus. Now magnitude wise, both F plus equals to F minus, and that is equals to Q into E. Magnitude wise, okay, magnitude wise both forces are same, which is equals to Q into E. Q is the charge, E is the electric field. So when you keep a charge in an electric field, what is the force acting on it? Q into E, right? Now the dipole, the distance between the dipole, say, is given by 2a. Okay, the distance between the dipole is generally given by 2a. So you have to draw the diagram carefully and point them properly so that there is no other confusion. So the distance is 2a. Now what you have to do, you have to extend this. So what is this distance? This distance is L, okay. So what is L? So if this angle is theta, then this angle will also be theta. So we can say that this is the hypotenuse, this is the perpendicular. So we can say that L equals to 2a sine theta. Sine theta is perpendicular by hypotenuse, so L divided by 2a is sine theta. So from there you can say that L is equals to 2a sine theta. This background work we have completed. Now what is the definition of torque? So definition of torque is magnitude of force times the distance between the force. Magnitude of 2 equal forces, when 2 equal and opposite forces acts on different points, okay, if you take the magnitude of any one force and if you multiply them by the distance between them, you get the torque, the magnitude of the torque. Okay, we are calculating the magnitude. So what is the force? Force is given by this, Q into E. What is L? L is given by this, 2a sine theta, or you can say Q into 2a into E sine theta. So what is q into 2a? For a dipole, q into 2a is called the dipole moment. So this becomes p e sine theta. So q into 2a becomes P becomes the dipole moment. So you have to mention P equals to Q into 2A equals to dipole moment. So whenever you are introducing a new variable, try to mention its name. Okay, or vectorially you can write torque equals to P cross E. Because there is a sine theta means it's a cross product. Okay, if you want to resolve the cross product, you get sine theta, right? So this is the final derivation, and very easy derivation. 3 marks is guaranteed if you can do this derivation. Now next question, what is a capacitor? Mention any 2 factors on which capacitance of a parallel plate capacitor depends. Capacitor is an electrical device used to store charges. Okay, so capacitor is an electrical device that used to store charges, that is used for storing charges. Factors on which the capacitance depends are, capacitance is directly proportional to the area of the plate, so that means C is directly proportional to area, and capacitance is inversely proportional to the distance between the plates, that means C is inversely proportional to the distance between the plates. Okay, so these are the 2 factors on which capacitance of a parallel plate capacitor depends. Now next, it's a 3-marker numerical question. So there, as I mentioned, 2-marker numerical question, 3-marker numerical questions, both will be coming. 3-marker numerical questions can be little tricky, so you can avoid if you are not sure about it, but 2-marker numerical questions are very easy, so don't miss out on them, solve them definitely. In a chamber, a uniform magnetic field of 6.5 into 10 to the power of minus 4 Tesla is maintained. An electron is shot into the field with a speed of 4.8 into 10 to the power of 6 meter per second. Normal to the field. Determine the radius of the circular orbit. So radius of a circular orbit is given by mv divided by qb. Divided by QB. So what is M? M is the mass of an electron, which is 9.1 into 10 to the power of minus 31. This formula you have to remember. Okay, if you remember this formula, this problem is very super easy. Velocity of the electron is given by this 4.8 into 10 to the power of 6 divided by QB. Q is 1.6 into 10 to the power of minus 19. What about B? B is magnetic field, which is given by 6.5 into 10 to the power of minus 4, right? So we have added this. Now you can use your calculator to calculate the value, and you will get this as 4.2 into 10 to the power of minus 2. 10 to the power calculation is important. This remaining values you can easily calculate. Okay, 16 infinity, you can cancel them, you will get 3 over here. Okay, 6.5 approximately you will get 4.2. Okay, so 4.2, and you will get 10 to the power of minus 31 plus 6. This will go up and become plus, so plus 19. This will go up, again becomes plus, so plus 4. So plus 4 plus 19 plus 6. So it is 29. Minus 31 plus 29 will give you minus 2. Okay, so minus 2 is the answer. So radius is 4.2 into 10 to the power of minus 2 meter, or if you want, you can convert it into centimeter as well. Not compulsory, but that is possible over here. So correct answer is 4.2 centimeter. Now let's move on to the next question. Mention any 3 properties of magnetic field lines. Very important. The magnetic field lines, again this question is also very important question. Okay, this question also have come multiple times in the paper. The magnetic field lines of a magnet from continuous closed loops. The tangent to the field line at a given point represents the direction of the net magnetic field B at that point. Two magnetic field lines do not intersect, for if they did, the direction of the magnetic field would not be unique at the point of intersection. Okay, so these are the 3 points. Next question, describe the coil and bar magnet experiment to demonstrate the phenomenon of electromagnetic induction. Even though this question has rarely has come in the board exam, but this question is one of the popular question in your pre-board exam. So be prepared, if you are writing for pre-board, this question might come. When the magnet is approaching the coil, so here we have a coil and a magnet. This is the coil. Okay, this is a magnet which is being brought near to this coil with some speed. Okay, what is happening as you are bringing this coil? When the magnet approaches the coil, the galvanometer needle deflects. Here we have a galvanometer which is deflecting when it is the magnet is approaching, indicating a current is induced. So when the magnet is approaching the coil, because current is induced, that's why the galvanometer, the needle galvanometer in the galvanometer deflects. Okay, when the magnet is pulled away, the needle deflects in the opposite direction. So when you are taking this magnet in this direction, suppose the galvanometer needle deflects in this direction. When you are pulling this away, the galvanometer needle will deflect in the opposite direction. Okay, showing that the current reverses. So whenever current, suppose the current initially was in this direction, when you are pulling it away, the current will be in the opposite direction. Okay, no current is induced when the magnet is stationary relative to the magnet, relative to the coil. So if you keep the magnet stationary, current induced is 0. So what is the conclusion? Very important about the conclusion, because it's a 3-marker question, you have to write the conclusion as well. Okay, this experiment demonstrate the electromagnetic induction. A current is induced when the coil, the magnetic flux through the coil changes. This confirms Faraday's law of induction, and the direction of the current follows the Lenz's law of opposing the change in the magnetic flux. As simple as that. Okay, conclusion are 2 lines. Okay, current is induced when the magnetic flux length is changed, and the direction shows the Lenz's law of electromagnetic induction. Now next question, draw the ray diagram for a formation of image by a compound microscope. Write the expression for linear magnification produced by the objective of compound microscope in terms of its tube length. Okay, for tube length of length L, the objective of focal length FO, the magnification is given by L by FO. Now this is a pretty standard diagram given in your textbook. You can practice it, but in my opinion, if this same question comes in your board, you should avoid it, because even if you are drawing it very carefully, small mistakes can reduce your marks. So if you have option, do not attempt any ray diagram based questions. Ray diagram based questions can be tricky, even though this can be a backup option. Suppose the question paper level difficulty was very high and there was one ray diagram question that you know, then invest some time and draw the ray diagram neatly and clearly. Okay, do not draw and override it. Compound microscope is definitely not an easy diagram. Simple ray diagram is still okay, but compound microscope 2 lens should be there. First lens is forming one image, that second image is being drawn by the second lens. So you need to practice this diagram if you are drawing this or if you are attempting this in your board exam. Okay, but in my opinion, you should avoid this type of question. Next, what are the matter waves? Explain the de Broglie hypothesis of matter waves. So matter waves, every moving particle, electron, proton, neutron, atom, molecule, etc., smaller particles obviously, behaves not only like a particle but also like a wave. So when a particle like electron, neutron, proton, atoms, molecules, they move, they do not only behave like a particle, they also behave like a wave. Now de Broglie hypothesis, every moving particle is associated with a wave, and the wavelength of this wave is given by lambda equals to h by p. Okay, lambda is wavelength, h is Planck's constant. Mention that. Okay, h is Planck's constant. And p is momentum. Okay, now next, differentiate between nuclear fission and nuclear fusion. Okay, nuclear fission is the heavy nucleus splits into two lighter nuclei is called nuclear fission. Fission means separation. Nuclear fusion, those who are some of you may be interested in music, listen to music. Fusion means when more than two different more than one kinds of musics are mixed together. That means when you mix Western music and Indian music together, then it is called a fusion. So fusion is two light nuclei combined to form a heavier nucleus. So fission is when one heavy nucleus that separates. Fusion is two lighter nuclei, they combine to form a heavier nucleus. Occurs in heavy elements like uranium-235, plutonium-239. Occurs in light elements like hydrogen isotopes, H2, H3 and helium as well. Releases moderate amount of energy, releases very large amount of energy, much greater than fission. Okay, so the energy released in fusion is much greater. That's why the sun, which is burning for thousands of years, and it will going to continue to burn for another few thousands of years, okay, in terms of billions of years, okay, so but billions may not be understand, so that's why I'm saying thousands and lakhs of years. Okay, and nuclear fusion is taking place inside sun's core, and that's why it is producing that much energy, and it is providing us warmth, it is providing us the required heat energy for us to survive on this planet. Okay, so releases moderate amount of energy, releases very large amount of energy. Reaction can be controlled in nuclear reactors. Reaction is extremely difficult to control, requires very high temperature and pressure. Okay, so if it is coming as a 3-marker question, any 3 is sufficient. I have given you one extra option if you are forgetting one of them. So basically, whenever you are studying a difference, try to, or properties, try to remember at least one more, so that in case you forget one, you can remember the other one. Now let's move on to the 5-marker territory. Now we are in the 5-marker territory. Derive an expression for electric potential at a point due to a point charge. So the most common most asked question in your PU board history. This came in the last year as well, might come this year as well. This question has a history of repeating every now and then. So not only, if you cannot predict that whether this question will come or not based on last year paper. Okay, so even if this question came in 2025 first paper, this might again come in 2026 first paper as well. Okay, now what is the derivation process? So if you have followed one of my previous lecture, I have discussed it in multiple ways. So today I am going to discuss very straightforward simple way, because we are solving the entire question paper. So A, B, so this is say at a distance x, the distance between A and B is dx, okay, and say this is infinity. Okay, so now let us understand the problem. So we are trying to find the potential at a distance P. Okay, electric potential at a point P. Now what is the definition of electric potential? Definition of electric potential is very simple. It says that you have to go to infinity. That is a major problem. Okay, infinity means, what is the definition of infinity? Infinity means the number or the length that you can imagine it is bigger than that. Okay, so infinity means a unrealistic number which is completely beyond our comprehension. Okay, any distance you can, okay, there are two types of infinity. One infinity is relative infinity. For example, if you consider the distance between say you and me, even from your mobile phone, whatever distance that I am from you, and if you consider the distance between you and sun, then relative to this distance, okay, that will be infinity. Okay, but in practically that is infinity, but realistically that is not infinity. Realistically you can go so many billions of light years, still it will not be infinity, right? So infinity is something which is very, very tricky to handle. Okay, but what we will be doing, we are smart, we are from a smart class of students, so what we will be doing, we will not deal with infinity directly. Okay, we will take some point which is not infinite, which is finite, okay, and that is a distance x, which is at a distance x from this charge, okay, which is at a distance x from this charge. And we say that what is the force acting on a test charge of Q. If you keep a test charge Q at point A, what is the electrostatic force that is acting on this? What is the electrostatic force acting on this charge? Electrostatic force acting on this charge is given by the magnitude of the test charge. Okay, this is the test charge. Okay, and the electric field at that point due to the original source charge. So what is the electric field at this point? Electric field at this point is, we know that it is given by K Q by R square into Q. Okay, K Q by R square, where x square is definitely the distance. Now this is the force due to the original charge. Now when you are talking about electric potential means the work done to bring a test charge. The definition says work done to bring a test charge. Now who will do that work done? So whenever in physics we say work done to do bring something, or work to done, that means work is being done by us, some external force. Us means external force. Okay, so external force that we need to apply, that should be equals to negative of the internal force. This is internal force, the force between two charges, Coulomb's force. But we want to bring that test charge by some distance, then the force that we have to apply is given by minus of F, that is minus KQ by x square. Don't forget this line. If you miss it, 1 mark will be deducted. Also the final answer that you will get will not match, you will get a negative sign extra. So don't forget this step. This is step number 1. Next is step number 2, calculating the work done. Now this force, as you can see, will vary with distance. This force will vary with distance. If you are getting close, the force will increase. If you are going far, the force will decrease, right? Because it is 1 upon x square. So definitely you cannot take this force and calculate the entire journey. So for that, what you have to do, you have to consider a small distance. This is a trick used by physics teachers or physicists. Okay, so what we will be doing, we will take a small distance and we assume that in this small distance AB, the force is almost constant. The distance is very, very small, so that the force is almost constant, and that the distance is given by dx. That distance is given by dx. Dx is a small distance. So what is the work done to move the charge from A to B? Okay, so the distance is dx. So what is the work done to move the test charge Q from A to B or B to A? Let me say, because we are traveling from infinity towards the point, so let's say it is B to A. What is the work done to bring the test charge from B to A? The work done is given by force that we have applied times the displacement, right? Work done equals to Fx cos theta. Here theta is 0 degree, sorry. Theta is 0 degree because displacement and force are in the same direction. So definitely it will be 0 degrees, so dW will be F external into dx. Now let's put the value. What is F external? F external is minus K capital Q small q divided by x square into dx. Okay, so this is the small work done to bring the charge by a small distance. Now we will apply the combination of integration. Okay, the concept of integration. What is integration? Integration means if you take such small distances and each time you calculate the force, each time you multiply with the displacement, and if you add them you will get the total work done. So integration means taking very small portions and adding them so that you get the total value. Okay, so integration dW starting from 0 to total work done W, okay, and that should be equals to minus K capital Q small q, they are constant, dx by x square, okay, from infinity to our point P, which is at a distance R. So when doing integration, we can take infinity safely. Under integration, infinity sits safely. Okay, so whenever you see some infinity in physics, definitely there is an integration involved. Okay, so dW integration is W, 0 to W means obviously W minus 0, that is W. Okay, so work done is W. On our left hand side we get W. What about on our right hand side? Minus KQ, Q is common. What is the integration of 1 upon x square? So 1 upon x square means x to the power of minus 2 plus 1 divided by minus 2 plus 1. So you get x to the power of minus 1 by minus 1, that is minus 1 upon x. So this is the integration of 1 upon x square. So you get minus 1 upon x limit minus infinity to r. Now minus value is common, so this will come out. So minus will be plus. So we get K capital Q, Q. And now we will put the limit. So first we will put the upper limit 1 upon R minus the lower limit 1 upon infinity. Okay, what is the value of 1 upon infinity? 1 upon infinity means any number divided by infinity is always 0. Okay, any number divided by infinity is always 0. So we get K capital Q small q divided by R. So this is the work done. Now potential at a point is defined by work done to bring a unit test positive charge from infinity to the point. So unit test positive charge means you have to divide by Q. So you get KQ upon R. Now last stage is still one step remains, that you have to put the value of K, that is 1 by 4 pi epsilon naught Q upon R. So this is the entire derivation, and I request you to practice the derivation at least 5 times. Okay, this will be the most important derivation, and if you practice this derivation you will get one question definitely in your pre-board exam, okay, or in your board exam. There is a high chance this question will come. Now let's move on. Assuming the expression for drift velocity, derive the expression for conductivity of a material, sigma equals to n square tau by m. So this is one of the easiest derivation. We know that current equals to NEA VD. Current equals to NEA VD, or I upon A equals to NE VD. What is I upon A? I upon A means current density J. It is called current density J. Now from Ohm's law we know that J equals to sigma E. This is Ohm's law. Alternative form of Ohm's law, right? So we will use this over here. So I upon A is equal to sigma into E. So sigma E equals to NE VD. Don't forget to, if you are using such directly, you have to use this as well. Don't ignore the bracket things that we are doing here. So from here we get sigma equals to NE VD upon E. Now VD upon E is called mobility, mu. Mu is VD upon E, and what is its value? It is E tau by M. Okay, so this is a well-known value, so we can use that in this equation, and we can say sigma equals to NE into mobility mu, or NE into E tau by M. Okay, this value we have studied in a same question, came as a 2-marker question as well. Okay, in case you forget, that should be your Q, E tau by M. So this is the sigma. Starting from drift velocity equation, we have derived sigma. Is very easy derivation, and if you get this derivation, you should consider yourself lucky. This is from current electricity chapter. There are a lot of other good questions that might come from this chapter, but don't expect that this question will come. This is one of the easiest derivation. Generally, this derivation used to come as a 3-marker, but somehow this question ended up as a 5-marker question. Derive an expression for magnetic field at the point on the axis of a circular current loop using Biot-Savart's law. So this is also one of the most asked questions. So here we have a circular current carrying loop. Okay, we are trying to find the magnetic field on the axis at, say, at a distance x. Okay, the radius of the loop is r. Okay, so this is the point x. Now there are a lot of steps involved. You should remember what formula you will be using. You will be using Biot-Savart's law. Suppose you take a small length element dl. Okay, the magnetic field at this point will be along this direction, and it will be dB. Okay, now if this angle is phi, this angle will also be phi. Okay, and only component that exists over here will be dBx, as y components will cancel, because if you consider a diametrically opposite point, then the y component will cancel, but x component will all in the same direction, they will be added. Okay, just diagram is sufficient, you don't need to write or draw everything, but the major things is this angle equals to this angle. Okay, theta over here is 90 degrees. Okay, so sin theta is 1. Okay, this is r. What is this value? This value is, say, small r, is given by square root of capital R square plus x square. Okay, now we will apply Biot-Savart's law. What is Biot-Savart's law? Talks about Biot-Savart's law generally says that magnetic field due to a current carrying element is given by mu naught by 4 pi I dl sin theta by r square. Here r is this value. Okay, remember r is from the component, so that means this is r. Okay, now here as I mentioned, sin theta is equals to 90, so sin theta is 1. So dB in this case is I dl by r square. Okay, but dB is immaterial because dB has two components, one is y, another one is x. Y component is not playing any role, so only dBx we need to calculate. So dBx is dB cos phi. So if you see this equation, what is cos phi? Cos phi is r by capital R, small capital R divided by small r, base by hypotenuse. So dB is mu naught by 4 pi I dl r square into, it will be capital small r divided by capital R. Okay, so for any triangle, any right angle triangle, okay, if this is your theta or phi or anything, then it will be always base divided by hypotenuse. Cos theta is base by hypotenuse. Okay, the same concept we have used over here. So now let's see, mu naught by 4 pi IR dl divided by r cube. So again, see, this is also a small portion. So small portion means what we have to do? We have to again do the integration. We have to again do the integration. So total magnetic flux is again our best friend, integration. I know many of you hate integration, but there is no other option. Okay, so dl over here is a closed integration. Integration is happening across this now. Previously it was happening from infinity to some point. Here the point is fixed, so no requirement of infinity or anything. Here integration is happening across this circle only. Okay, you are taking small dls and adding them. Okay, because remaining portions everything is constant. So you can write over here mu naught by 4 pi, okay, IR by IR cube integration dl. What is integration dl? Here integration dl is basically, if you take small dl, you will get the circumference of a circle. Circumference of a circle means what? 2 pi r. That's it. Nothing, no rocket science. So this will be mu naught by 4 pi IR. I made a small mistake and nobody cared to make me correct, right? So here it will be IR divided by R cube. Be careful, don't make the mistake that I have made, right? So dl is 2 pi here. Be careful again, it is not small r. By habit, you should not write 2 pi small r. It should be 2 pi capital R. Why? Because the radius of the circle is capital R, and this is the circumference of the circle. So 4 pi 2 pi cancels, you get 2 over here. So from here you get Bx equals to mu naught by 2 IR square divided by small r cube. Small r cube means this cube, that means r square plus x square to the power 3 by 2. This is the formula, this is the derivation. If you practice it, this is much easier derivation and steps are very small. So if you practice this derivation can be achieved easily without much difficulty. Now let's move on to the next question. What is a wavefront? A wavefront is an imaginary surface that connects all points in a wave that are vibrating in the same phase. Derive Snell's law for a plane wave undergoing refraction using Huygens principle. So this is the question that we are going to answer. Suppose there is two medium. One medium is this, another medium is this. Light ray is traveling like this. So light, this is ray number 1, this is ray number 2. After entering the second medium, they all bend, and because they are initially parallel, after refraction also they will be parallel. Okay, so if this angle is incident angle, this angle is refracted angle. Okay, if this is the incident wavefront, this will be the reflected wavefront. This will be the reflected wavefront. And if this is an incident wavefront, this angle will be I. If this is a refracted wavefront, this will be R. Okay, the diagram you have to memorize. If you try to understand the diagram, it will be very complicated for you, at least for your level. But the diagram can easily be remembered. Now what you have to do, remember that the speed of light, suppose in this medium is say V1, the speed of light in this ray is V2. Okay, and if this is incident wavefront, this is reflected wavefront, then you have to remember that the time taken by the light to reach from here to here, say A to B, okay, the same time is taken by light to reach from C to D. Okay, so AB, time taken to reach the light from A, time is important, not the distance. Okay, distance is not same. So time taken by light to reach from A to B is same as time taken by light to reach from C to D. Then only it will be reflected wavefront, because this light is arriving at point C before than A. So by the time light is arriving here at C, the light is at A, the other ray is at A. Now by the time the light ray is arriving over here, the second ray already entered the second medium, and this is the refracted ray. Okay, now what you have to do, you have to prove the Snell's law of refraction. Okay, so now first what we will be doing, we will consider this is I, this is R. Now this is the wavefront, that means this angle is 90 degrees. Similarly here this angle is 90 degrees as well. Okay, so first we will try to see what is sine I, because we know that in Snell's law it is the relationship between sine I and sine R. So we will see what is sine I. Sine I. Sine I is given by here. So this is the right angle, this is the hypotenuse, okay, and this is the perpendicular, right? So perpendicular divided by hypotenuse, that is AB divided by CB. Okay, so this is sine I. Now what is AB? As I mentioned, the time taken by light to reach from A to B is same as the time taken by light to reach from C to D. Now speed is V1, time is T, then we can write AB as V1T divided by CB. Okay, V1T divided by CB. Now what about sine R? We will similarly we can write sine R will be V2T divided by CB. You can check that out. Similarly you can write it over here, no need to check. Sine R equals to perpendicular divided by this. Now this perpendicular is again V2 into T. So similarly you can write the statement. Now what we will be doing, we will be simply doing sine I divided by sine R equals to V1T divided by CB divided by V2T divided by CB. CB cancels and you get V1 by V2. Okay, V1 by V2. Now what we will be doing, we will do a small trick. We will do C divided by V2 divided by C divided by V1. Okay, we have done a small change. Okay, so V1 was in the numerator, so it will go down and it will be division of division. Okay, so here we can write this as refractive index of N2. It will be refractive index of the medium N1. This is the medium of refractive index N1. This is the medium of refractive index N2. Okay, so if you do the cross multiplication, you will get N2 N1 sine I equals to N2 sine R. This is the general form of Snell's law. Okay, small derivation, but you have to write the description of this diagram, which is very important. Okay, for that you can go a textbook or any reference book. Okay, if you really want me to dictate this, then I will do that during the chapter wave optics in Brahmastra series. You can go and check that out when it will be available. Okay, there I will completely describe the diagram as well. Now let's move on. What is a half wave rectifier? Draw a neat labeled circuit diagram and input output waveforms for half wave rectifier. Explain the working of a half wave rectifier. Very common half wave and full wave. Out of that, full wave is most commonly asked. Half wave was also asked, but either half wave or full wave will definitely come in your board exam. So definitely prepare both the rectifiers. One of them will come in your board exam. A half wave rectifier is an electronic circuit that converts alternating current AC into direct current DC by allowing a current to flow only during one half cycle of the AC signal. The other half cycle is blocked, so only the half of the AC wave is used. So here you can see this is the circuit diagram of half wave. Practice the circuit diagram, practice the output input waveform, which is very important. Okay, diagrams has to be perfectly drawn using pencil to draw it. Okay, and then you have to mention what is input, what is output, and diagram should be clear. It should not be very thin that you need a microscope to watch it. Okay, the diagram should be bold enough. Use HB pencil if possible. Okay, or later on if you draw it, you can mark using a black color pen. That is also fine, but it should be very clean and pristine, so that the teacher will definitely wants to give you full marks, not want to deduct any marks. Okay, Next, working positive half cycle of AC. During the positive half cycle of the AC input, the anode of the diode is positive with the respect to the cathode. The diode becomes forward biased and conducts current. Current flows through the load resistance RL in one direction and the voltage across the load is positive. During the negative half cycle of the AC input, the anode of the diode becomes negative with respect to the cathode. The diode is reverse biased and does not conduct. No current flows through the load resistor RL and the output voltage is 0 during the half cycle. Okay, so positive half cycle, negative half cycle, both you have to mention. If you are not confusing with anode and cathode, you can use P and N. Okay, P side is positive, N side is negative, the current conducts. In the other case, N side is connected with positive, P side is connected with negative, diode does not conduct. So that is also fine. Okay, instead of anode and cathode, you can mention P type, N type. Now let's move on to the numerical questions. So question number 42. This is a long question. A positively charged spherical conductor of radius 0.1 meter produces an electric field of 1.8 into 10 to the power of minus Newton 10 to the power of 3 Newton per coulomb at point P, distant 0.2 meter from its center. Calculate the magnitude of the charge present in the spherical conductor. So first stage, we have to find the charge present in the spherical conductor. Also find the magnitude of new charge produced on the same spherical conductor if 5 into 10 to the power of 10 extra electrons are removed from it. Okay, so we'll solve it one by one. First stage, let us understand what is happening. We have a spherical conductor which is of 0.1 meter radius, and we are trying to find the electric field at a distance of 0.2 meter. Okay, we are trying to find electric field at a distance 0.2 meter. Okay, that is a point outside the spherical shell. Okay, spherical conductor. Okay, so this is small r, this is x. So for x greater than small r, what we can say that the electric field is given by, the electric field equation is given by K charge enclosed in the conductor divided by the distance square for any point where x is greater than r. Okay, for any point x greater than r, this is the formula for electric field, and here that electric field is given over here, which is given by 1.8 into 10 to the power of 3. Okay, so 1.8 into 10 to the power of 3 equals to, what is K? K is 9 into 10 to the power of 9, and charge we are trying to find. We do not know the charge, so we will keep it as Q. And what is x? X is given here as 0.2 meter. So no need to convert any units, 0.2 meter. Okay, so we get Q equals to 1.8 into 0.2 whole square into 10 to the power of 3 divided by 9 into 10 to the power of 9. So this will be cancelled, you get 0.2. So 0.2, 0.2, 0.2, that is 0.008. Okay, into 10 to the power of 3 divided by 10 to the power of 9. You can use calculator if you are confused. Okay, what I have done, I cancelled 1.8 with 9, we got 0.2. This 0.2, another 0.2, 2 0.2s are here in the square. So 2 into 2 into 2 is 8. So 0.2 into 0.2 into 0.2 will be 0.008. 3 decimals should be there. So now we can say that 0.008 into 10 to the power of 3 is 8. And this will go up and it will become minus 9. So minus 9, 8 into 10 to the power of minus 9, and this is charge unit is coulomb. So from here we can say that 8 nano coulomb. So this is the first stage. Okay, if you solve up to this much, you will get 3 marks. Next part, if you solve, you will get another 2 marks. So what is the second part? Second part says that also find the magnitude of the new charge produced on the same spherical conductor if 5 into 10 to the power of 10 extra electrons are removed. So if you remove 5 into 10 to the power of 10 extra electron, then what will be the excess charge? First of all, excess charge we will calculate, and then depending on whether it is a positive or negative, we will add or subtract. Now if you are removing extra electrons, definitely the charge that is gaining, it will be positive charge. The charge that we had is positive, the new extra charge will also be positive. So let us consider the excess charge. Excess charge. So excess charge is given by, we know that from quantization principle, Q equals to N into E. This is only the extra charge that we are calculating. What is N? N is 5 into 10 to the power of 10. Okay, and charge of an electron is 1.6 into 10 to the power of minus 19. Now 5 into 1.5 into 16 is 80. 5 into 1.6 is 8. So it will be 8 into 10 to the power of 10, 10 to the power of minus 19. So it will be 10 to the power of minus 9. So extra charge will again be 8 nanocoulomb. But this is not the answer. Again, we have to find the new charge. So what is the new charge? New charge should be the old charge plus the extra charge that you have added or taken away. So it will be 8 nanocoulomb plus 8 nanocoulomb. That is 16 nanocoulomb. So the charge on the conductor is 8 nanocoulomb, and the charge that you have after doing everything, the final charge is 16 nanocoulomb. So solving up to this 3 marks, solving this you will get 1 extra mark, and solving this will give you full marks. Now let's move on. The terminal potential difference of a cell connected to an external resistance of 4 ohm is 2.4 volt. When the same cell is connected to an external resistance of 9 ohm, the terminal potential difference becomes 2.7 volt. Find the EMF and the internal resistance of the cell. So first of all, we have a cell. Cell means it has an internal resistance, and you are connecting it across an external resistance, say capital R. And if the current in the circuit say I, then the terminal voltage, so this is R, this is epsilon, okay, then the terminal voltage is given by epsilon minus IR, no matter whatever is the external resistance. This is the formula for terminal voltage. Okay, now you have to calculate this current I. How to do that? Current I is given by epsilon divided by small r plus capital R. Okay, so first stage we will use this to eliminate whatever is the value, and then we will add this. Okay, let's see step by step. So first stage is when this resistance is 4 ohm, the terminal value is 2.4 volt. So for case 1, external resistance is 4 ohm and the terminal voltage is 2.4 volt. Now what is the expression for current? We know that current is equals to epsilon divided by R plus small r, right? This expression. Now if you multiply, you will get I into R plus I into small r equals to epsilon, okay, or I into R equals to epsilon minus IR, right? So what is epsilon minus IR? It is equals to the terminal voltage. So this is nothing but your terminal voltage. So what we got from here is IR is the terminal voltage. So I equals to terminal voltage divided by the resistance. So this is the case number 1. So current, I am saying the current is I1. Okay, so let's say this is I1, and we get what is terminal voltage. Terminal voltage is 2.4 and resistance is 4. So this is 0.6 ampere. So we have calculated I1. So again we can use this equation. So epsilon minus 0.6 small r equals to 2.4. This is our equation number 1. Okay, because we have to find epsilon and r, we have to go back to this equation one by one. Now again for case 2, because we have done some mathematics, we are not going to do that, repeat that steps again. What we will be doing, we will be directly calculating I2. So I2 equals to again V upon R. Now what is V over here in case 2? V is given by 2.7 and resistance is given by 9 ohm. Okay, so I2 will be 2.7 divided by 9, that is 0.3 ampere. So I2 we have calculated. Same formula. Once we have done the mathematics, we can use the formula again, right? So now we will use the second formula, epsilon minus I2. I2 means 0.3 R, and that is equals to 2.7. This is our equation number 2. Okay, so now what we have to do, we have to eliminate. It's very simple elimination. Let me write the equation number 1 below this. So 0.6 R equals to 2.4. Okay, so let me subtract them. So this becomes minus, this becomes plus, this becomes minus. So epsilon cancels, we get 0.6 minus 0.3, that is 0.3 R equals to 0.3. Okay, 2.7 minus 2.4 is 0.3. So from here we get R equals to 1 ohm. Now we just need to take that value and put any one of the equation. Okay, let me use the second equation. So we get epsilon minus 0.3 into 1 equals to 2.7, or epsilon equals to 3 volt. So easy question. Only thing is the question is something uncommon, otherwise no complicated circuit diagram, no complicated calculation, everything is straightforward starting from your simple cell equation. Okay, so 3 volt 1 ohm is the correct answer. If you have knack of solving problems, then this question should be easy for you. And if you are only hoping to solve some pattern questions which is coming repeatedly, you only want to practice them and solve it, then this question is not for you. For you, you have to solve the next question. First question was a simple pattern question. This question is also a pattern question. Okay, this question are also getting repeated every year. Similar question, same concept question. A resistor of 10 ohm and inductor of self-inductance 0.05 Henry are connected in series to an AC source of 200 volt 50 hertz. Find the impedance of the circuit and current in the circuit. So first of all, here it is only an RL circuit, so very easy question. So RL circuit means only a resistor and an inductor are connected in series. Okay, and with an AC source, values are given 10 and 0.05, 50 hertz, 200 volt. Okay, first of all you have to calculate. So whenever you want to calculate the Z, remember in your back of your mind, for LCR circuit the value is R square plus XL minus XC whole square. Now here no XC is there, so XC is 0, so that means XC is no longer there. So what is the impedance? Impedance will be simply R square plus XL square. Okay, XC is no longer there, right? Very simple. So we will calculate XL. What is XL? XL is called inductive reactance. Inductive reactance, which is generally given by omega L if angular frequency is given. If normal frequency is given, then 2 pi f into L. Okay. So 2 pi into f is 50 hertz, L is 0.05. Okay, 2 into 50 is 100, 100 into 0.05 is 5, so it will be 5 pi. Okay, what is pi? Pi is 3.14. So if you multiply, you will get 15 plus 0.7, so 15.7. So 15.7 is the inductive reactance. So this is unit is in ohm. So what is the impedance now? So impedance will be square root of R square is 10. So 10 square plus 15.7 whole square. If you calculate it, you should get some 16.6. If I am not mistaken, you will get some value around 16 point some expression. Again, to get the answer, correct answer for this chapter, you have to use calculator to get the final answer. Now what is current? Current is given by the voltage that you have applied divided by the impedance. Okay, voltage is 200 and current, the impedance is 16.6. So you will get the answer as 18.6. You will get the answer as, this is 18.6 and it will be 10.75. 10.75 ampere. Okay, if you just, it's a calculation part, you can use your calculator to calculate it. Only thing that you have to use a calculator to get the answer. So this is part A answer, this is part B answer. But you have to be careful, you have to use the units in every stage. Okay, if you miss the unit, marks will be deducted. Last question of the sample paper. A double convex lens are to be manufactured from a glass of refractive index 1.55 with both faces of the same radius of curvature. Find the radius of curvature required if the focal length is to be 20 centimeter. Also find the new focal length of the lens if it is immersed in water of refractive index 1.33. So first of all, what equation will be using? Yes, lens maker's formula. So 1 upon f equals to n minus 1 upon r1 minus 1 upon r2. This is the general formula of lens maker's equation. Now for equiconvex lens, lens, r1 is equals to minus r2 equals to rc. Okay, so the sign of r1 and r2 are opposite and magnitude wise both are same. So r1 is equals to r and r2 equals to minus r, right? Just put that value. So what you will get? So lens maker's equation becomes 1 upon f equals to n minus 1 by r minus r. Okay, this is minus, right? So this minus becomes plus, so you get n minus 1 2 by r. Okay, if you remember this equation, very good. If you are doing it, you have to derive this equation in this particular case as well. Now f is given here as 20 centimeter and initially it was only in air, so the refractive index is given by 1.55. so just put these values, you will get 1 upon 20 equals to 1.55 minus 1 into 2 by r. R we are trying to calculate. So r equals to 1.55 minus 1 is 0.55 into 2 into 20. Okay, just cross multiplication. So you get 0.55 into 2 is 1.1. So 1.1 into 20, or this will be 22 centimeter. So radius of curvature is 22 centimeter. Now next part, they have said that also find the new focal length of the lens if it is immersed in refractive index 1.33. Now this is tricky. First part is easy, direct lens maker's formula, easy. Second part is tricky. So when you immerse a lens into refractive index n1, then here you have to divide this by that second refractive index. Okay, everything else remains same. So we will start with our previously derived equation, this one, and we'll say that in water, say focal length is f dash, it will be n original n divided by refractive index of water minus 1 into 2 by r. This formula we have already derived, right? So from here we can calculate. Now what is n by nw? N is 1.55 and nw is 1.33 minus 1 into 2 by 22. So it is guessed 1 by 11. Now let's simplify. 1.33, 1.55 minus 1.33 into 1 by 11. Okay, now you are trying to find f dash, so you have to take the reciprocal, so 11 will go up, so 11 into 1.33 divided by 1.55 minus 1.33, that is 0.22. If you simplify it, you will get 6.65 centimeter. Okay, you can use a calculator to calculate the focal length. So you will get 22 centimeter is the radius of curvature, and once it is immersed in water, the 20 centimeter focal length becomes 6.65 centimeter. Okay, clear? Now, so if you have any doubts, any more questions, please don't forget to ask me in the comment section below. I'll be back with more new lectures very soon. Till then, bye.